Hello everyone, my name is Pierre-Hugues. I'm a senior IT consultant and the author on Java support patterns at blogspot.com. Today's video will be about the pattern number 2 of our series, which is describing the problem, a common problem, java.lang.NoClassDefFoundError. In case you didn't have a chance to look at the first video, I highly recommend that you look at it because it covers the most common problem, which was basically a class path related problem. This video is about to explain also a common problem, which is our pattern number 2, which means static initializer failure. Okay, so this is the pattern that we'll cover today, which, as you will see, will lead also to java.lang.NoClassDefFoundError. So I hope you will enjoy this video. So in order to deep dive into this problem, we created the sample Java program that we call java.lang.NoClassDefFoundError simulator training 2. The source can be found from the blog, the article that I wrote, that you can see as a link in this video. So let me explain how we created this simple Java program. Well, as you can see, it's a fairly simple Java program. It has just 2 Java classes, one main program, a Java class named NoClassDefFoundError simulator. And what this program does is fairly straightforward, right? So it's creating a new instance. It's attempting actually to create a new instance of class A. And then it's going to catch any exception here. And it tries this for a first time, kind of simulating what you would do in a real world, right? So let's say you're building a web application. The first request attempted by your users, for example, the JVM has, before creating a new instance, the JVM has to do a class loading, right, of your Java class, right? In this case, class A. So JVM will do class loading. And then after the class loading is done, you will be able to create new instances of this class over and over. But first, the JVM has to do a class loader call of this class, right? And this is what we're trying to simulate here, right? That the NoClassDefFoundError, as you saw from the first video, will only tell you that the JVM was unable to load this class in its class load at runtime, but it doesn't give you any detail of why. So the JVM won't give you the root cause, for example, if it's missing the class from the class path, or if it's static initializer code, or if it's a class loader issue. So that you pretty much need to figure it out yourself. Okay? So I won't be going over too much detail about the class loader for now. So today we're just going to cover the static initializer failure. Okay? So back to the program. As I said, we try one first attempt to create a new instance, and then we try a second time and a third time. And why we're doing that, right? Second time and third time? Well, the intent is that the first attempt, as I mentioned, a brand new JVM, the JVM has to do a class loading call. And so we'll see what happened when this class loading failed for the first time. And then we'll also see, after the class loading is failing, what is the error thrown for the second and third attempt, and so on. Okay, so that's what this program is going to do. So that's the main program, right? Very straightforward. Now let's have a look at the class A. So in the class A, we build the class A in order to simulate 2 problems. I hope you're familiar with static initializer. If you're not, then probably just a quick 101 is that when you're writing Java programs, you can build a static block like this. So you can do some static initialization, right? So let's say you have a data cache you want to load, for example, only once in a JVM lifetime. Then you could use a static block like this, meaning that this code will be executed by the JVM only once in its lifetime, from a class loader perspective, right? So that code is only executed at class loading time. And this is precisely what this program is all about. What we'll demonstrate today is that if the code that you execute, that JVM executes basically in the static block, if that code fails with an unexpected exception or unhandled exception, then this is going to prevent the class loading of the class and lead to no class def on error, right? So this is very important that we realize that, because when you get a no class def on error, you should not assume right away it's a class path issue, right? You also have to look for this pattern as well. So the class A was built to show you two problems. So it's very straightforward. So we just put a replicate problem 1 to true, and then depending on the pattern, it will execute the proper simulation. So two ways to replicate. One is to simulate the failure of the static block, which is one way. The other way is to use a static variable as well. So not only static block, but let's say you create a static variable. In this case, we call it static variable as a string. It's a static variable. And the static variable is loaded from a private static method called static variable, in a static variable, which is basically, if replicated enabled, it will throw an exception. So it simulates the same thing, either via a static variable or static block. If we throw an unhandled exceptions, it's going to prevent the class loading of this class A, and that's what we're trying to prove here. Okay, so now let's execute this program. Okay, so let's see what happened. Okay, so what you see here is just basically the logging that we put here, right? And then we get to the first attempt of program. Let's see what happens. So we got an exception right here. Exceptions in initializer error. Oh, so yes, this is what we were trying to show, right? So let's see where we got this exception. So obviously that exception got triggered here, right? I just click on this link, right? Class A. So we got the JVM did throw an exception in initializer error when we're trying to initialize a class A. This is exactly what we're trying to replicate. Now let's see what exception that we got, right? Well, in this case, we're trying to replicate the problem 1. As you can see, problem 1 was enabled, static variable. And then this method was simply throwing an exception instead of initializing the string error. So because an illegal state exception was thrown by our method, the JVM is then returning an exception in initializer error. You see? So it's preventing the creation of the instance. Okay, so far so good, right? But still no class found error at this point yet. Okay. Now let's see the second attempt to create an instance of class A. Second attempt. What did we get? Oh, look at this. No class def on error. Right here. And what about the third attempt? Same exceptions. You see? So this is very important for you to understand, right? So no class def found, as I mentioned. Why are we getting no class def found here? Well, it's because this code, right? This code that failed right here. As I mentioned, as per JVM specification, the class loading attempt is only attempted once in a JVM lifetime. So if you write basically code with setting initializer, that code will be executed only once, regardless if it's successful or not. Okay, if it's successful, you're good to go. You know, the class will get loaded and so on. Now, if it's not successful, it doesn't matter. It will still get executed only once. But the side effect is the class is not loaded to the class loader. Very important, right? So the class is not loaded to the class loader. Probably the JVM would have been good maybe to have some extra messages like JVM not loading the class, you know, similar to help us out there. But anyway, right now it's throwing the exception initializer error. So it's giving you a hint, right? When you see the exception, it means the static initializer failed. And then the no class def on error is the side effect of this error, right? So it's very important that you realize that, because you may be scratching your head and trying to figure out, well, maybe this class is not in the class path. Maybe you see, well, in this case, obviously it is in our class path. It's getting executed. So don't get confused. It is in our class path, but the static block or the static variable in this case is not loaded properly, which is preventing the class loader. So the root cause is this, not this. This is showing you the error after the fact, right, or as a side effect. So that's why it's very important, right, when you investigate no class def on error, that you also look for errors such as this one, exception in initializer error. Because you may realize that, okay, well, this is after the fact, but you need to debug is this one, is why the static block is failing as at the first place. Okay, and in our case it's because we're voluntarily sending an exception. Now let's try with the second case, right? Again, it's the same thing. This time we're just going to simulate the failure of this block right here, sending the same exceptions. You see, first attempt. Okay, just some logging there. I'm just going to re-execute, but it's essentially the same thing. First attempt, right? Again, failure the same place. Now let's see. This time it's failing right here, right? Because we just changed that to true. We're throwing the exceptions, simulating let's say internal error in any program. The illegal exception is sent back, unhandled exception. The JVM is throwing back exception initializing error. As I mentioned, the class is not loaded in the class loader, and then any subsequent call to this class or attempt to create an instance will throw no class def on error, as you can see right here. So this is what we wanted to confirm. So as I mentioned, it's very important when you see this error, and when you're pretty much sure that you're not dealing with a class path error, do the additional due diligence and look in your log, making sure you're not dealing with exception initializer error in your log. The other way also is to look at this class, right? If the JVM is complaining about this class, right, have a look at this class. If it's your application code, open your code and look for any static variable which may have failed, like a block like this would be suspicious, or any static variable calling method like this, right? Or it could be a logger, for example. You see, a common issue I've seen in the past is a logger failure. So let's say you're trying to load a log4j logger, for example, and maybe this logger is not loading properly. Let's say a configuration problem one. If this logger instance is loaded statically, then this would prevent the class loading of your class. Exactly what we're trying to simulate here. So that's a common problem I've seen in my past experience there. So again, as I said, now that you understand the pattern, it should be easier for you to go in your application logs and code and determine if your code is exposed. And the best practice, if you're writing static block like this and variable, is to add some error handling on top of it, right? So, well, maybe you want the whole class loading to fail, but a better way would be actually to add some error handling and shield you against that type of issue. Okay, so I hope you enjoyed today's video, and I suggest that you have a look at the article, and the next video will be the part 3, and we'll start to look at some of the no class def on error issues which can be caused by more advanced class loader related problems. Okay, so have a good day.